Welcome back, everyone. So with this lesson, we'll reintroduce how to create a file in C, but the learning objective after that will be how to use variables. And what do we mean by variables? In other words, how do we utilize memory space to store data and retrieve data from it, okay? So let's start with a new C program. So I'm just going to go over here, and you could see here I'm using Dev C++. You could use whatever IDE you choose. And I'm going to click here to get a new file. So now what I have here from the tab, it says untitled. I haven't saved this, so probably is a good idea to save it now. So I'm just going to hit save, and it's going to ask me where do you want to save it. Let me see here, file, save as. And there you have it. I'm going to store it in a directory for, in our case, under C intro, variables and pointers. So these are some of the items I'm going to be covering today. Another thing is you want to make sure that your file has an extension .c, not .cpp. So I'll start with that so I won't make a mistake. So it's a C source file .c, and then name it whatever you want. So I'm going to call it var ex1 as variable example1. And I'm going to save that right here. So now what I have is a C file, right? A C source file, but I haven't written any source code yet. So if I try to compile this to produce an application, I will definitely get an error. So let me just show you the error you will get. So if you say compile, you will get an error here. It says it's missing a specific function called main that you need at minimum to have a C program running. So again, let's review that quickly. Int main, so if you had this, okay, and let's return 0 back to the operating system. Again, that return 0 is optional, but it's always a good idea. Let's compile now and see if we do get an error. And good, so no news is good news, so we're in good shape here. So what we would like to do now is declare variables. And we would like to see the behavior of what's going on when you put data in those declared variables, and then when you retrieve the data. So if you're going to retrieve data and be able to see it on the screen, you're going to need a library file that allows you to print to the screen. So let's go ahead and start with that. And that's called a directive line. So that # include, and that would be stdio.h. So that is the standard input-output header file from the standard library that allows us to do a printf to the screen. So we can, remember we did something like this, printf, hello there, right? And semicolon. Now, if I compile and run this, now for my program, it went a little too fast. So sometimes it's always a good idea, if you're in C, to create another function called, so you can actually print to the screen a message that interacts with the operating system. And that message with the operating system is called pause. So this will hold the screen for us. And this is really running a DOS command called pause. So now let's see how this behaves. So let me compile and run. And there you have it. Now we have hello there, press any key to continue. So we're going to do that. So that would have been the introduction to do a hello world or a hello there lesson. We want to do a little more than that. We want now, and let me write a comment now. Anytime you want to write a comment in C, in its pure form is a /* and then whatever the comment is, and then you end it with */. Notice the color on the IDE. That line will not be interpreted if you compile your program. You shouldn't have any problems right now. So you can see no issues whatsoever. But what I would like to do is whenever I write a comment, I would like to write something that makes sense. What is it I'm doing at this stage? That's called inline documentation. So right here, I'm going to declare variables. And we'll start with 1. Okay? So what does it mean by declaring a variable? It means you're asking the operating system that's controlling memory, because this computer is talking to it, to reserve a space, right, for the variable that you're going to declare. And it's going to say, well, how do I know how much space in bytes you're going to need? Aha, you're going to tell it what data types, what kind of data you're handling. So if you did something like this, int, you are handling an integer. So that's the declaration. The int is a data type. And then the variable name, my var. And then semicolon. Semicolon means ends that instruction line. This simply means, hey, computer, knock, knock, give me some space for my var of type integer. So that means you're going to get 4 bytes reserved for my var. Now, I want you to go down later on. I have another lesson within this course that talks about how memory is managed. Okay? So please go there to get an idea where my var in the address space of memory it's actually stored at. Okay? But right now we know within the stack of main, we have control over this local variable called myvar. So I'm using syntax here, or words that are formal as to what myvar is. It's a variable. It's a local variable that belongs to the function main. When main runs, it runs within a certain stack. Okay? All right, so when we run functions, we're going to have stacks. Within that, you're going to have local variables. So I have a local variable called myvar uninitialized, which means I did not give it any value. So if I try to print what's in it, I am most likely going to get garbage. So how would I print what's in myvar? You would do something like this, printf, and then notice how you splice up there will be a string here and a comma, and then myvar, and put a semicolon. Now I'm going to put something in here in this string value here that will extract whatever is in myvar. So printf is a function that takes 2 parameters, right? So this myvar argument is the variable that I would like to say, hey, I want you to print it right here, %d. And just to show you what else we can do here, printf, let's say I do a /n. /n is not a variable. It's simply an escape character. That gives me a new line. So that way I can see what's in my var without it being attached to press any key to continue. Now let's see how this runs quickly. Compile and run. And notice I'm getting a little error here. Let's see why. And that's okay. Maybe I named it something else. Aha. Yeah, so my var, so naming your variables, you have to be consistent. So notice here, my lowercase v, uppercase v. So you have to be consistent. Another thing, if you intended to name it your variable, do not put a space like this. Okay? One word for the variable name. Could you have done an underscore between them? Yes, as long as you keep it consistent between the two. Could I have put a number in front of it? One myvar. No, do not put a number in front. Could I have put a number behind it? Absolutely, it's okay. As long as you refer to it or refer to it back in this manner. That means these two are consistent. So myvar 1, fine. Let's keep that and let's see what happens now. Compile and run. And notice we get some value printed out. 16384. Now, we had no control over this value. What it's doing, right where %d is, it's printing that value based on what's in my var 1 right now. Well, where did that value come from? It came from whatever data was already in memory before we actually ran this program. So it's garbage, okay? So if you're going to print the content of a variable, you need to assign a value to that variable. So how can we assign a variable a value? So let's go ahead and, so this one here was output the content of the variable. So that's fine, but now we need to assign a value for the variable if we intend to print it. Okay, so we're going to do that here. So my var 1, so stay consistent with the naming, is going to be equal to, let's say -3, semicolon. Absolutely legit as to what -3 is, or legitimate, right? It's a negative integer number. Integer values have to be whole, so no decimal points, okay? Right, so we will talk about the numbering system again, and we're going to talk about integers and floats so we can differentiate between the two. So let's go ahead and run this for a minute, and notice now I do get my var. Now, what about initializing a value? Let's go ahead and do that right here. So you can declare another one, int my var2, but this time with the equal sign, equals 6. Now, this in particular, this is a declaration and an initialization. So we simply say this is an initialization. That's the term for it. So that means when we declare it, we give it a value ahead of time. Could I display what's in that one? Absolutely. Now, just to make it interesting, notice this printf here. I can type something like this, my var1 equals. Now, what's going to happen is you're not extracting the data right here. You're extracting it in this, what we call a placeholder. All right, so %d is for data that's in as an integer, stored as an integer. So that will help you there differentiate this with this. This here will just simply print as a string literal to the screen. We're going to do the same thing for printing the content of my var2 equals, and then put your %d, right? Oops, %d. Otherwise, you're not going to be able to see the value that you're trying to look at. So in our case, my underscore var2, and make sure you close with a semicolon. Now let's see how this behaves. So compile and run. And there you have it. Now, notice between the two, I had no hard return. Okay? So my var1 equals -3. My var2 equals 6. Now, could I have put a printf/n in between them? Absolutely. Is there a shortcut to do this? Yes. You could do it right here, /n. That gives me a new line right now. As soon as this is executed, give me a new line. And what's going to happen is this will be in its own line. Can we put a /n here and get rid of this printf here? Absolutely. That would make it a little more compact and more consistent. Okay, well, let's see how this behaves now. Let's compile and run. And there you have it. My var1 equals -3 in its own line. My var2 equals 6 in its own line. Press any key to continue. That came out of system balls. So what's the lesson out of this? One is that my var1 was declared, and then we assigned a value to it. My var2, on the other hand, was initialized, so we did not need to assign a value to print it out. Now, what would happen if you assign a value to my var2? Then it will change. Okay, so for our next video, we will handle variable manipulation. So we're going to change variables, their values stored in the variables. That's why they're called variables, okay? Because whatever they store can vary depending on what you wrote here, what we call it compile time, and then we'll have examples with runtime examples where, hey, how about me putting numbers while the program is running into the program? Okay? So we will see a lot of examples like that as we move forward. So hopefully you learn a lot here, how to declare a variable, how to initialize a variable, and how to print its content